So one of the reasons that functions come in handy is because we can use them to come up with some real-life modeling formulas. So for example, I might say express the volume of a cube we'll say the volume of the cube is V as a function of its side, or of the length of its side, maybe is a better way. So as a function of the length of its side, we'll call that side S. Well, if you think about a cube, all the sides are the same length. So the length is S, and the width is S, and the height is S. So the volume of this is just S cubed. So we could say that V is equal to S cubed. This is a function with respect to S, where S is the input value and V is the output value. And actually maybe a better way to write this would be V of S is equal to S cubed. This is saying that the volume is a function of the lengths of the sides of the cube. So this is like a common way that you would take this and put it into more of a real-world application. Something else we could do is say that there's a company has a startup cost of $5,000. And they would say for each item they sell, or maybe I should say for each item they make, that would be a better way. For each item they make, they have an additional $200 of costs. Okay. So maybe you're making something in your factory that it costs you $200 to make it. You're going to sell it for more, but for you to buy all the raw materials, pay the labor, pay somebody to put it together, and pay for all the equipment that you need, it's going to cost you $200 per device. Then maybe your startup cost is $5,000. Maybe this is what it takes to rent the space that you need maybe to buy some equipment. This is our initial cost here. So if I want to write a function, so we'll write a cost function C in terms of the number of products made and we'll say that the number of products made is given by the letter X. I'm writing a function that's a cost function that tells me the cost based on how many of this particular product that I make. So, for example, I know that my cost is going to be my startup cost, my $5,000, plus every X of these that I make, I'm going to have to spend $200 per unit. So if I make 5 of them, for example, it would be 5 times $200. So I can write that the cost was the initial cost of $5,000 plus $200 times every X, every number of the objects that I make. If I make 10 objects, for example, then I would put in X equals 10 here, and be 10 times 200, so 2,000 plus 5,000. So it would cost me $7,000 total to make 10 of these products. And in fact, you could use, the nice thing about this function is now that you have this value, you can just plug in whatever value you want to here for X, and then your output value is going to be the cost that it's going to cost you to make. You can easily throw that into a computer. The computer will calculate however many values you want it to calculate for you if you want to see the differences in cost for making certain numbers of products. So another example I can use the geometry for to come up with one of these functions is something like this. Say that you have a piece of cardboard, it's a square, maybe 20 inches on this side and 20 inches on this side. And what I'd like to do is cut corners out of each side of the square. Cut the corners out and then fold up the flaps on the side to make a box. So you have to excuse my drawing skills, but our box would end up looking something like this. Okay. And I'm going to say that each of these units that I cut out we don't know what it is. It's going to be X units long. It's a variable on both sides. So we're going to count these little squares all around the same value. So what I would like to do is I would like to write the volume of this box as a function of x. So as a function of the size of the cuts that I'm going to do around the box. Well, let's think about what happened. The box is open, so I'll do that to show that it's open on the top. Well, if this is x, if you think about folding the box up, that means that this height here is x, okay? And that's the height on all the sides. What is this dimension going to be, though? Well, it used to be 20 inches, but whenever we take off x units from one side and x units from the other side, this actually becomes 20 minus x minus x. So 20 minus 2x would be the short length right here. And in fact, that's the same length right here as well, because this was 20, and then we're subtracting 2x off of that. So that means that actually my length here, this side, is 20 minus x. And then my length here, this side, is also 20 minus 2x. And this length there is also 20 minus 2x. So the volume of a box is always just the length times the width times the height. So the volume of this particular box would be 20 minus 2x times 20 minus 2x times the height, which is x. So this is the length times the width times the height. So we actually get a function that is 20 minus 2x squared times x. So you can see where this would be useful to be able to make the function, because now every time, if I want to figure out what are all of the possible volumes that I can get out of this box by making different size cuts for the squares, I only have to put this together one time. And now I can just change the x value in this particular formula and see how that changes the volume. I don't have to go through this whole process again of trying to visualize it and figure out how big my box is going to be. Because now I can say, well, what would happen if I made 1-inch cuts in my box? What volume would I get? Well, I would get a volume of 20 minus 2 times 1 squared, all times 1. Just plug in 1 for x. And then, I'm sorry, this should be parentheses right there. So I could figure out this volume really easily. Or I could say, well, how does that compare to if I make a 2-inch cut? Okay, so then the volume would be the same thing, 20 minus 2 times 2 this time, squared times 2. And you can see how the volume changes. You can see maybe what cut you should do to get a maximum volume, or what is the most economical sizes that you should make for the cut. But again, the idea is that I've already made the function. So now I can keep changing my x values here, just plug them into the function to see how the volume is going to change. I don't have to go through this whole process again. I just have to go through it one time, create the function, and now all of a sudden I have all of this information compiled into this one easy to read